Imagine a future where mining the moon isn't science fiction, but a real, working industry, where robots roam the lunar surface, digging through ancient regolith to extract one of the rarest materials known to science, helium-3. It sounds far-fetched, and to many in the commercial space industry, it still is. But one company, Interlune, believes it's not only possible, it's inevitable. Let's be honest, building a massive harvester that can crawl across the moon, sift through hundreds of tons of lunar dirt, extract a few kilograms of helium-3, and then get that precious material back to Earth. It's a logistical, engineering, and economic nightmare. Many space experts have dismissed the idea as fantasy. The costs are astronomical, the physics punishing, and the return on investment uncertain at best. But for Interlune, a Seattle-based startup led by aerospace veteran Rob Meyerson, this challenge isn't a deterrent, it's a mission. In 2025, Interlune announced a major milestone, a partnership with Vermeer Corporation, a heavy equipment manufacturer known for industrial machines in agriculture and construction. Together, they built and tested a prototype lunar excavator, not on the moon but here on Earth. This experimental machine ingested a staggering 100 metric tons of simulated regolith per hour, proving that large-scale lunar excavation can actually be feasible. It was far from a final product, but as CEO Meyerson put it, we demonstrated that we could pull that much material through at a certain power output. We gathered the data we needed for designing the next version. So, why go through all this trouble? Why helium-3? Helium-3 is a stable, rare isotope of helium with only 2 protons and 1 neutron. On Earth, it's nearly non-existent, found only in trace amounts from nuclear tests and reactors. But on the moon, without a magnetic field to deflect solar particles, helium-3 from the solar wind has been accumulating in the regolith for billions of years. It's often touted as a potential fuel for nuclear fusion, offering clean energy with no radioactive waste. But that dream is still decades away. Instead, Interlune sees a near-term opportunity: cryogenics. Helium-3 is critical for refrigeration systems that cool quantum computers to near absolute zero down to 0.2 Kelvin. It's already in demand, and it's already expensive. Interlune isn't just dreaming. They already have customers. One is Maybell Quantum, a quantum infrastructure company that agreed to buy thousands of liters of helium-3 between 2029 and 2035. Another customer, the US Department of Energy, who agreed to purchase 3 liters harvested from the moon no later than April 2029. This isn't speculative science fiction. This is a supply chain starting to take shape. So how does Interlune plan to make this a reality? It all begins with a prospecting mission scheduled for 2027, a small payload under 100 kilograms, hitching a ride on one of NASA's commercial lunar payload services, CLPS landers. Think of it as a lunar recon mission, mapping, analyzing, and locating helium-3 rich areas. In 2029, Interlune plans to deploy a pilot plant, depending on which launch vehicles are available. If SpaceX's Starship is operational for lunar landings, the plants could be larger and more capable. If not, they'll scale accordingly, potentially flying smaller units on other platforms, like Blue Origin's New Glenn. By 2032, Interlune envisions launching a solar-powered mining operation. This would include 5 mobile harvesters, processing stations, and a system to return extracted material to Earth. The entire setup would weigh 40 metric tons, a massive logistical operation. But within the capabilities of a single Starship, there's a New Glenn MK to south. It's bold, it's risky, and it's expensive. But if they succeed, they'll make history. Interlune's timing may be just right. The US government's space policy is shifting. China has already sent rovers to explore lunar helium-3 deposits and is advancing its human spaceflight ambitions on the moon. Meanwhile, with Jared Isaacman stepping away as a NASA nominee, the Trump administration is reportedly eyeing retired Air Force General Steve Quast as a potential replacement. Quast is a vocal advocate of helium-3 mining and a lunar-focused strategy, this changing political landscape could funnel more support and funding toward companies like Interlune. Of course, none of this happens without serious capital. After raising $15 million in 2024, Interlune is gearing up for a new round of fundraising. They'll need hundreds of millions, if not billions, to scale operations, build lunar infrastructure, and overcome technological hurdles. But with real partners, real customers, and a roadmap in motion, investors are starting to take notice. And in a field dominated by satellite internet, space tourism, and launch startups, Interlune's mission stands out. They're not selling data. They're not offering zero-gravity joyrides. They want to dig up another world and bring its secrets back home. Interlune's story is about more than Helium-3. It's about the first real steps toward building a lunar economy, a self-sustaining industry that justifies the cost of going to the moon not for science or flags but for profit, progress, and the raw materials needed for humanity's next leap. If they succeed, they could become the cornerstone of a new space frontier. But make no mistake, they have a long way to go, and a lot of regolith to sift through. Mining the moon once sounded like science fiction. Now, it's becoming a blueprint, and Interlune is daring to draw the first lines. If you enjoyed this deep dive into the future of space mining, hit that subscribe button and turn on notifications. Want to bring a little space into your life? Check out our list of 10 awesome Amazon space-themed products linked in the description below. This is Dynamic Trends, where innovation meets imagination. Thanks for watching.